Okay, so we want to find out the true bearing to the aircraft plotted on a Lambert's chart. So because we're on a Lambert's chart in the northern hemisphere, we have to put our lines like that, getting closer to the top, and then we need to figure out what side are we starting. Are we starting out on the left hand side or the right hand side, the east or the west? In order to do that, we need to work out, well, where are we going, you know? Are we travelling east or west? The way to do that is to look at this sort of relative bearing indicator and our magnetic heading. We're given the magnetic heading of 185 degrees, which means that if the variation isn't massive, we're going to be going south. So I'm actually going to flip this over like this, and then with the RBI, which is 65 degrees, then think about, okay, where's the NDB? If it was 65 degrees, it's measuring from where our aircraft is heading to where the NDB is. And 65 degrees would be off to the right. So that means we're on this side, going that way. Okay? So I'm going to put it like that, and because we're going south, I'm going to put it near sort of the top. And now, just to convert the 185, we're going to convert it to true, because when we work on charts, we only want to be doing stuff in terms of true. So that's 185 over there, and it'll be 6 east. The reason is, well, because we care about where we are and not where anything else is. So that's why we picked that variation there. And then, so because we're going from 185 to true, well, from magnetic to true, we're adding on the 6 because we're going in the easterly direction. So we add up and we get 191 degrees. So that means we're heading, well, a bit more than this 180 degree line there. So I'm going to flip it around again, and I'm just going to draw it directly down and say that this angle here is 11 degrees. Okay, and we also we're told that our relative bearing over here is 65 degrees. Okay, well, I'm sort of drawing this upside down now, but oh well. So this straight line that I've drawn right here, this is on the relative bearing indicator, but we need to also understand that this is a great circle, okay? This is not a Rhumb line, it's a great circle, and that's the way we do our bearings off of. However, because it's a bearing and it's a great circle, its track's going to be changing, unlike a Rhumb line. Flipping it back round again, so, you know, we know that we're in the northern hemisphere. I'm going to put the Rhumb line in then. Because it's in the northern hemisphere, it's going to be going like that below. And yeah, that's meant to be 65, that's meant to be 11. Sorry for that. Bit rushed. But oh, my PC is going off. Can't see the question. Right. So now we have this 11 and 65 here. We know that this angle, we can add them up. So I'm just going to write 76 degrees there for that big angle there, and we can add 180 there. So then we add them up, plus 76, my mental maths is pretty rubbish, so we get 256 degrees. And that's what that big one is there. And that is our sort of great circle track. So our great circle track of 256 degrees, that's to get to the NDB. But now we need to work out the bearing from there sort of back. In order to do that, we can convert from the great circle track here to the Rhumb line, because we know that's going to be the same. And what we do there is subtract this conversion angle here. Our Earth convergency is 8 degrees, and the conversion angle is half of that. So convergency of 8 degrees, we're going to subtract 4, because that's the conversion angle. So we get our Rhumb line track is 252 degrees. And then that's going to be 252 degrees there and 252 degrees over here. That angle all the way around there. And then, well, we want to find it the other way around. So 252 take away 180. That gives me 72, which is going to be this big angle here. But we don't want that. We want the the bearing, right? The true bearing, and that's going to be a great circle. So that might be 72 degrees, but we want to subtract this angle here, which is 4 degrees again, and that gives us our 68 degrees, which is our answer. Instead of sort of subtracting the 4 degrees twice, you could have just done it once with the sort of convergency, but this is a more step-by-step method.